Hi everyone, I'm In Dong Jia, MVP in Visual Studio and Development Technologies. Today I'm going to talk about initializing and optimizing machine learning model. Today's agenda will cover using hyperparameters, using multiple algorithms and models, scoring and evaluating models. Let's start with using hyperparameters. Let's start with teach you how to choose parameters to optimize your algorithm. There are 4 steps in the process of finding the best parameter set. First, define the parameter space. Second, define the cross-validation setting. Third, define the metric. Fourth, train, evaluate, and compare. For the two models hyperparameter, the term parameter and hyperparameter can be confusing. The model's parameters are what you set in the property pane. Basically, these modules perform a parameter sweep over the specific parameter setting and learn an optimal set hyperparameter which might be different from each specific decision tree dataset or regression method. The module supports 2 methods for finding optimal setting for a model: integrated, train, and tune. Cross-validation with tuning. For the using multiple algorithms and models, consideration when choosing an algorithm: accuracy. Getting the most accurate possible isn't always necessary. Sometimes an approximation is inadequate, depending on what you want to use it for. If that's the case, you may be able to cut your processing time dramatically by sticking with one more approximate methods. Another advantage of more approximate methods is that they are naturally tend to avoid overfitting. Training time. The number of minutes or hours necessary to train a model varies a great deal between algorithms. Training time is often closely tied to accuracy. One typically accompanies the other. In addition, some algorithms are more sensitive to the number of data points than others. When time is limited, it can be drive the choice of algorithm, especially when the data is large. Linearity. Lot of machine learning algorithms make use of linearity. Linear classification algorithms assume that classes can be separated by a straight line or its higher dimensional analog. This includes logistic regression and support vector machine. Linear regression algorithms assume that data trend follow a straight line. This assumes isn't a bad for some problem, but on other that bring accuracy down. Number of parameters. Parameters are the knob of data scientists get to turn when setting up an algorithm. There are numbers that affect the algorithm behavior, such as error tolerance or number of iterations or options between variants of how the algorithm behaves. The training time and accuracy of algorithm can sometimes be quite sensitive, getting just right setting. Typically, algorithms with large number of parameters require the most try and error to find a good combination. Number of features. For certain type of data, the number of features can be very large compared to the number of data points. This is often the case with genetic data. The large number of features can be boiled down some learning algorithms, making training time unfeasibly long. Support vector machines are particularly well suited to this case. For scoring and evaluating models, Scoring is widely used in machine learning to mean the process generating new value given a model and some new input. The generic terms of score rather than prediction, because scoring process can be generate so many different type value. A list of recommended item and similarity score, numeric value for time series models and regression model, a probability value indicated the likelihood that a new input belongs to some existing category. The name of a category or cluster to which a new item is more similar, a predicted class or outcome for classification model. List of scoring model. Machine Learning Studio provide many different scoring modules. You select one depending on the type of model you are using or type of scoring task you are performing. Apply transformation. For evaluating models, the machine learning evaluate category include the following module: cost validate module, evaluate models, evaluate recommended. Let we go for a demo. This demo will teach you how to create a tune models. Let's back to the Azure Machine Learning Studio. Click on New Experiment. Then we search for a dog and drag and drop. Then we go select us. We search again split data. Then drag and drop and connect it. In the split data of fraction, we change from 0.5 to 0.7. Then we search for vector, vector. Then we drag beside a split data, and this will change the create trainer mode. We change to a parameter range. Then we check for use range models. We change. No, it's not this one. Use the range models. We select the one. You change the 1 to 100, and the number of points you change for the 4. Then we go to set again the split data. We need one more split data. And drop under the another for the first split data. Then for the property space, we fit the rows fraction of rows is to a 0.6. Then we connect each other first. Then we go for the we need a tune models. Then we change the tune model hyperparameter. We change the entire grid. Then we click on launch column setting. We select income. Then we connect the two class models to tune to the left. Then we need a split data. We use a central. Connect to a central. Oops. Then the other we connect to this. Okay. Now we need a score models. Then we connect this one. Then we need a first split data to connect to the split models. Then we need a evaluate. Then we connect it. Then we click on run. Take a minute to train the models. We wait for so long for the train the models. Now it's into model hyperparameters. We left two models that not yet run. Okay, you finish one is finished. You click for output of the evaluate model, you create a visualize. Then you will see the following result. ROC receives recall and leave. The end for my demonstration. You can refer the following resources. Thank you.